physics aficionados! Welcome back to another episode of Thermofication. Today, we're going to be diving into the fascinating exploration and creation of homemade thermometers. Moreover, we'll also delve into the concept of thermal expansion in various colors. However, before we start our wonderful, lustrous, and knowledge-inducing experiment, what exactly is thermodynamics or thermofication?
Glad you called, Katrina. Thermodynamics is a branch of physics that deals with the study of energy, its transformations, and the properties of matter under various conditions.
To add on that, Guile, it also encompasses the principles and laws governing the behavior of macroscopic systems, describing how energy is transferred between different forms and how it influences the properties of matter.
Whoa, that's pretty insightful. Thanks, Guile and Sarah. Now, before we dive into our experiment, let's call Aisel to drop a quick reminders for you.
Let's talk safety. When you're in the experiment zone, it's a must to gear up. Lab coats, gloves, and safety goggles are your superhero ensemble. Why, you ask? Well, these aren't just cool accessories. They're your shield against unexpected splashes, spills, and other dangers. Safety first, always!
Now, without further ado, let's peek behind the curtain and unveil the materials utilized and the methodology and data collection for this experiment. Emily and July, take the floor.
For the materials, we'll be needing alcohol, pentel pen, modeling clay, 4 water bottles, 4 food coloring, blue, red, yellow, and green, and 4 drinking straws.
The first thing that we're gonna do is we're gonna fill these 4 water bottles with rubbing alcohol. Make sure to put them carefully and don't forget to fill each of them with an equal halfway amount of rubbing alcohol, which is equivalent to 100 ml. The next step is we're gonna put 3 drops of different food coloring for each bottle. 1 for yellow, 1 for blue, 1 for green, and lastly, 1 for red. After mixing it all up, we're gonna put 1 clear straw for each bottle. The next thing that we're gonna do is we're gonna mark each bottle at the alcohol level with a pentel pen. This will reveal whether or not there are any changes as a result of the experimentation. After that, let's seal the bottle opening with clay and secure the straw in place. Remember to ensure that the clay makes an airtight seal around the straw over the bottle's mouth, but do not close the straw's opening.
Of course, science isn't always smooth sailing. Let's discuss any hiccups we encountered and how we crunch the numbers through error analysis. Show us the Einstein way, Isa.
Now, we all know that making a homemade thermometer can be fun, but to achieve accurate and reliable results, it's essential to go beyond its making phase. We must take a closer look at the potential errors that may arise. Firstly, the inaccurate calibration of the temperature markings. We must make sure to calibrate the thermometer against a known reference to ensure accurate readings. Secondly, the external factors such as wind, weather, and temperature. It is inevitable that these factors affect your experiment. Thirdly, consider how the variations in material properties can introduce errors. In this experiment, we must note small things such as tightly wrapping the clay around the bottle and not letting the straw touch the bottom of the bottle. Last, human error. It is inevitable that we humans make mistakes. Whether in reading or handling the thermometer, we must make sure that we use the standardized methods and follow the procedures properly to minimize any errors.
Now, we've come for the moment we've all been waiting for. The results! Brace yourselves for a burst of siren.
Wait a second. Let me sprinkle in a little fun fact. Did you know that the brain power behind thermodynamics is Sadi Carnot, the father and the genius who laid the groundwork for the fascinating field? Now, let's get back to the experiment and dive into those results.
The examination of our thermometers revealed noteworthy distinctions in temperature readings among the various colors. According to our data, the red thermometer displayed moderate temperature changes, registering at 9 degrees Celsius at 10 a.m., 6 degrees Celsius at 12 noon, and 4 degrees Celsius at 2 p.m. Conversely, the blue thermometer demonstrated a more erratic pattern, with readings of 9 degrees at 10 a.m., 6 degrees at 12 noon, and 4 degrees Celsius at 2 p.m. The green thermometer distinguished itself by maintaining values commencing at 9 degrees Celsius at 10 a.m., reaching 6 degrees Celsius at 12 noon, and decreasing at 4 degrees Celsius at 2 p.m. Finally, the yellow thermometer exhibited diverse values ranging from 9 degrees Celsius at 10 a.m. to 6 degrees Celsius at 12 noon and descending to 4 degrees Celsius at 2 p.m. These disparities suggest that each color exhibits distinct thermal behaviors, possibly influenced by the composition of rubbing alcohol and food coloring.
Thanks for that comprehensive report, Sarah. Now, let's put our analytical hats and dive into the whys behind the what.
So guys, these are the results for 10 a.m., 12 noon, and 2 p.m. According to the data gathered, there has clearly been a thermal expansion since the alcohol thermometer was exposed to the sun. Every color has a different height change. They all differ because different colors reflect or absorb various parts of the light spectrum. Blue and yellow thermometer colors absorbed more heat than the other colors, with yellow having the greatest change in height with a range of 8 ml to 24 ml. Colors such as red and green, on the other hand, did not absorb as much heat since they did not have a greater change in height, with green being the lowest with a range of 4.5 ml to 0 ml change in height. This experiment contradicts earlier research claiming cool colors are actually warmer than warm colors, because yellow, a warm color, has the greatest change in height and volume, while green, a cool color, has the smallest change in height and volume. This study, however, may not be applicable to this experiment because alcohol has faster thermal expansion than water, because alcohol molecules are smaller than water molecules, causing alcohol to evaporate more easily than water.
As we wrap up our thermification journey, what have we learned today, team?
We learned that thermal expansion is the general increase in the volume of a material as its temperature is increased.
We can create homemade thermometers with just the use of water bottles, straws, alcohol, and food coloring.
As the temperature changes, the alcohol inside the straw either expands or contracts, causing the liquid inside to either rise or fall.
The variations in color result from differences in chemical composition, impacting thermal expansion properties as the arrangement of atoms or molecules affect the material's response to temperature changes.
Keep in mind that this homemade thermometer is more of a qualitative indicator and may not provide precise temperature readings. It's simply an engaging way to understand how temperature affects the volume of liquids in a closed system. You can use a separate thermometer to calibrate and correlate the color changes with actual temperature readings if you want a more accurate representation.
And there you have it, folks. What a marvelous journey through the vibrant world of thermification. In conclusion, we've witnessed how each color dances to its distinctive thermal turns, from the fiery expansion of red to the cool composure of blue. It's clear that thermodynamics shapes the very essence of color. So, next time you see a rainbow, remember, it's not just a visual feast, but a testament to the unseen symphony of energy and matter. Until our next colorful adventure, stay curious and keep exploring the wonders of science. See you soon, physics aficionados! Bye!